Hello guys, so we're back with another video. Today we're going to look at inline value classes and if we have time, object declarations and expressions. So I'm going to start right away with reading the documentation as my IDE is currently updating. I will need to confirm the update. Just a second. Okay, while it goes on, we can read. So sometimes it is useful to wrap a value in a class to create a more dynamic specific type. Okay, okay, so the class may be more domain specific type, sorry. So, however, it introduces runtime overhead due to additional heap allocation. Okay. Moreover, if the wrapped type is primitive, so yeah, if the wrap type is primitive, the performance hit is significant because primitive types are usually heavily optimized by the runtime, while their wrappers don't get any special treatment. So if the wrap type, so the type that I'm wrapping is primitive, then the performance is significant because primitives are heavily optimized by runtime, while their wrappers don't get any special treatment. So like the integer that you wrap is optimized, but if you wrap it, it's not optimized anymore. To solve such issue, Kotlin introduces a special kind of class called inline class, which are a subset of value-based class. Okay. They don't have an identity and can only hold values. So they don't have an identity. What it means, I don't know. And to declare an inline class, use the value modifier before the name of the class. Okay, so you have to use value. To declare an inline class for the JVM, use the value modifier along with JVM line annotation before the class declaration. So to declare an inline class for the JVM backend, okay. An inline class must have a single property initialized in the primary constructor. At runtime, instances of the inline class will be represented using the single property. So as you can see here, no instantiation of class password happens at runtime. Yeah, at runtime, secure password just contains string. So our secure password at runtime, secure password just contains string. This is the main feature of inline classes, which inspired the name data inline. Data of the class is inlined into its usages. So yeah, which is data of the class is inlined into its usages. I want a clearer understanding of this, and to do so, we'll write ChatGPT to give us a better overview. So let's see, what is the purpose of inline class in Kotlin? So in Kotlin, inline classes, now replaced by value classes in recent versions, are used to wrap, inline or value classes, okay, are used to wrap a single value without the runtime overhead of object allocation while maintaining type safety. So the purpose is to avoid runtime overhead. They allow you to create a wrapper around a value, integer string, without creating a new object. The JVM sees only the underlying value. For example, if you have two integers, Values that mean different things like user ID and product ID, you can wrap them in different classes to avoid mixing them by mistake, okay? They provide allocation while keeping performance close to that of primitive apps. So that's the usage, for example, that you can have. Very similar to the example from them. At runtime, the JVM will use the plain integer most of the time, avoiding extra allocation. But the compiler enforces that only a value user ID can be passed to the get username. They cannot have init blocks, can only wrap one property, cannot have mutable properties. Quality and hash code behave like the inline type. I would say, what's the difference with type alias? So as you can see, there's no type safety. There's no compile time check on type alias. And can have behaviors, so methods, you cannot have them. And you can have API clarity encapsulation with inline classes or value classes. So yeah, these are value classes. Yeah, they should be named value class. Okay, now let's try and open our Leet. Kotlin with Luca. And let's go to our source. Where is the app? Here we go. Sample app. Okay, now we can comment our classes here. And we can go with inline values. Inline value. Let's create testing. Okay, it's installing something. Yeah, IntelliJ backend. And now we will create our first function. It can be password, which can be anything. Let's create inline values. Testing function. And here we say, yeah, we have to create a folder, not a folder, sorry. Yeah, maybe a folder, like username. And here we say password dot p. And here we have inline value. Yeah, we have to define it like value class, sorry. Value class, and then password, and then we pass a string. Now we have our password here, and we can define it like we always do. So val secure password, and we can say password here. Here we pass something like ciao. Now we'll need to import this. Yeah, now that it has finished with its stuff, we have imported this. Let's see what issues we have. Yeah, we have to step val s first of all. Yeah, value classes without JVM annotation are not supported yet, so you must have JVM inline annotation. Okay. So now we have, just to have a recap, we have all of these features here. In comment, refactor. How do you comment this? I don't know the shortcuts here. So we have runtime object. No, it's not a runtime object. Type safety. We have type safety. We have better performance due to fewer allocations. And we have constraints. Only one property allowed. So this might be useful for you to store any data that needs type safety and where you want good performance. So as we said, you can have multiple parameters here. You must have exactly one. That's probably a disadvantage here. Inline classes support some functionality of regular classes. In particular, they are allowed to declare properties and functions, have an init block, and secondary constructors. So you can have an init. So like yeah, you could require something like require password s is not empty, and else you just the require will throw the legal argument exception with a lazy message that you can bring in. So like password is required to log in. Okay. And then we can have our constructor first name, last name. Yeah, because we have full name here. So let's create, as we do, a person, pt. Let's copy this, username, full name, and let's say full name. All right. And then we can have another constructor with like first name, string, last name, string. Then we can have, yeah, we have to call our primary constructor, of course, which is this. And then we must pass first name, last, yeah, space and last name. And then here we need to remove them because we're in a constructor. We only pass them to use them in the secondary constructor. And then here we can as well require something like yeah, like last name is not empty, and then say last name must not be empty. And we have our example similar to this one. We can compute length. So full name length. Here we must specify it. Why save delete? Valid class cannot have properties with vacuum fields. So yeah, we need to we use the get. Why am I not getting second? Oh, not here. I'm unable to get parentheses. Okay. Then, yeah, now we have the full name, but we cannot have a backing property. Then we can have a function test, line test. This is also allowed. And then, yeah, we can do whatever we wish with the person. So val like person. Hello. A dependency? What? Oh, it's the name. Okay. Person. Import. Person one, person two. Me as surname. So this will throw some exception. Will it throw an exception? No, because we're passing full name. If we're passing an empty person, then we will get the exception. An empty secondary, sorry, an empty last name. In fact, if we try to do this, person 1, 2, 3, then we'll surely get an exception. Yeah. As you see, last name must not be empty. Unchecked cast. So let's just try and catch argument exception. So we print person 3 first, we print 1 and 2, and that's fine. All right, so we have person 1 and 2, and there it goes. Inline classes cannot have backing field. They can only have simple computable properties, no late init or delegate. So that's what we tried just a few seconds ago, and we have had an issue. Inline classes are allowed to inherit from interfaces. So yeah, of course you can have an interface like print length and we can have this inside an interface that we have here. This is for Oh. Nope. Fun. What am I doing? So this is a function friendly. All right. Now you need to override, of course. And this is also allowed. So you can have like person 1 as interface person. Yeah, you don't need even to call that, but that's the idea. You can pass the interface directly into println. You see here. You can pass the interface instance So yeah, you can say this is let me bring length. Now it should be more even better. So if we create a function, we don't want a person, but an I person, so that an instance object. Yeah, an instance of the interface, and then we can say person directly without having to access the class implementation, and this will behave the same. All right. Because here basically you're doing an is as I person without explicitly saying it. So that's it. We have done this. This forbidden for inline classes to participate in class hierarchy. This means that inline classes cannot extend other classes and are final. So it is forbidden. Yeah, this means that inline classes cannot extend other classes. Like if I try to extend password, it will tell me the type has a constructor and must be initialized. This is final, so it cannot be inherited from. Value classes can only extend classes. Yeah, value classes cannot extend classes. So you cannot do this. Then we have representation. In generative code, the Kotlin compilers keep a wrapper for each inline class. Inline class instances can be represented at runtime either as wrappers or as underline type. This is similar to how int can be represented either as a primitive int or as the wrapper integer. The Kotlin compiler will prefer using underline types instead of the wrapper to produce the most performant and optimized code. However, sometimes it is necessary to keep wrappers around. As a rule of thumb, inline classes are boxed whenever they are used as another type. So they're boxed when they're used as another type. Boxed uses a generic type T or I. Boxed as foo. And here it's used as foo itself. Below F, first is boxed while being passed to ID and then unboxed when returned from ID. Okay, so in the end, C contains unboxed representation 42 as F. So it is first boxed and then unboxed. In the end, C contains unboxed representation just 42 as F. Okay, let me check. Okay, this touches on performance and memory, which is super relevant in Kotlin. Boxing means wrapping a primitive value, so an integer, into an object, and unboxing means extracting the value back. So boxing is turning an integer into an integer object, and unboxing is turning integer into an integer primitive. So the JVM differentiates between primitive types like int double, very fast, no object overhead, and object types like integer and double, needed when working with generics, collections, nullable types, and so on. So also, if you have nullables, this will mean that they will be boxed into an integer. If you have a pure integer, it will be not boxed. So basically, boxing will introduce some delay. So these three functions, like, yeah, all of them will introduce some delay, and as inline, it will not introduce any delay. That's the advantage here. That's what they're trying to tell us, that this first one, as inline, it will, since it's unboxed, it's faster. That's what they're trying to do. Yeah, we could have this example also in our code here. Interface. Yeah, our interface is like personal. And then we can say this one is boxed, unboxed. Use as person itself. And here we have box. Use a generic type. Uses I person. And here it's used as person, which is different from foo. Since it is nullable. And below F, first boxed while being passed, and then unboxed when returned. So this is also not very efficient. All right. Because inline classes may be represented both as the underlying value and as a wrapper, referential equality is pointless for them and is therefore prohibited. So inline classes can also have a generic type parameter as the underlying type. In this case, the compiler maps it to any question or generally to the upper bound of the type parameter. So you can have a generic and the compiler will generate the compute hash code S. Okay. Yeah, I don't know if we would use this. I don't know what's the purpose here of this. But you can do so. Mangling. Since inline classes are compiled to the underlying type, it may lead to various obscure errors. Mangling. For example, unexpected platform signature clashes. Okay. uint also represented public final compute int on the JVM. So yeah, this could lead to an issue. So I mean, you wouldn't do that. To mitigate such issues, functions using inline classes are mangled by adding some stable hash code to the function name. Okay, so they should be, yeah, you should be able to run that because it will be represented with the hash code, dash hash code. So it's a hack that they have here. You can call functions that accept inline classes from Java. To do so, you can manually disable mangling and add that JVM annotation before the function declaration. Okay, so you can rename this function whatever you wish, like compute uint, and you can use it in Java. This is if you are building a very specific library that can be used in Java. Inline classes versus type aliases. So at first sight, inline classes seem very similar to type aliases. Yeah, that's what I thought too at the beginning of this. Indeed, both seem to introduce a new type, and both will be represented as the underlying type at runtime. However, the crucial difference is that type aliases are assignment compatible with their underlying type, and with other types with the same underlying type, while inline classes are not. In other words, you introduce with an inline class true newly to type, and contrary to type alias, they do not introduce a new type, but they bring you an alias. So it should be better to use inline classes when you, for example, want when you want to have the things that we said before, like type safety, compile time check will be quicker because there will be compile time check since they are treated as a new type. And then so instead with type alias, you can exchange them with the original type, and then you have runtime behavior, same as the original type, and inside here they're optimized wrapper unboxed at runtime, but of course you also need to you need to be careful with the nullables. And then you can add behavior methods. Yes, you can do that here with the inline class, and it's better also for API clarity and encapsulation. So it's a lot better. Good. Let's go back here. So let's say we have our type alias here, and we pass in except string, we pass in a string. Yeah, you're passing basically name type alias as a string, and accept string will accept the alias. And in case of an inline value class, it will not accept it. So I think overall we shouldn't use type alias, we should use inline values instead. Let me do an example here with the password. Type alias, password, alias, and then we have string. So the weak point here is that if we have a function like create create password, and we say create functional, and here we pass a string, Oops, yeah, we pass it there. Like my password. Yeah, here we can do password alias. Yeah, we cannot do this. We have to do something like s alias password alias, and then we can say password alias, and then here we have password. Our password will be password, and here we pass password line value, and then we have here our alias. This is allowed. This is not allowed because it's a new class. So we have type safety. We will need to create a new class. Yeah, that would be better to call it password alias as password inline value. Are you kidding me? And that would work out. Okay. And of course, here we have a password instance, and here we have a string instance. You see? Okay. And let's go. Yeah, last thing, which really doesn't matter, is that you can also have this one. And you cannot do this with by passing p. Okay. Inline classes and delegation. So implementation by delegation to inline value of inline class is not allowed with interfaces. So implementation by delegation to inline values of inline class is not allowed with interfaces. So let me say, yeah, let's say we have an interface with two functions. Then we have an interface wrapper. So we're passing in an instance, yeah, an interface object or class. And this is going to be an interface, yeah, a class of an interface, my interface, by an interface. And this is the object that we pass in. So we can have my interface wrapper. Inside, you can pass an object of type my interface. And here you can override bar or full. So that's interesting. I would need to understand the use of this, but maybe let's ask ChatGPT like let me see. It's not exactly what I wanted to have. Function callback. But it's something. Yeah, like let's call the SDK example. And here let's call it sdk.at. So we have SDK interface. And here we have our SDK interface wrapper. Now we have our callback, which is used in this function. So like, I don't know, do something. So we're calling, yeah, we're overriding do something here. And we're passing in a callback. And this means that we can call the callback on success and on failure methods. And of course, we can do that if we have success, for example, or if we have failure, depending on what we receive from the function. So like we could have our function returning a Boolean. No, it's not like this. The other thing that I want to do. How do you do this? Do something. Yeah, because I'm passing the object to do something. The callback object. Okay. Yeah, so basically the idea here is that you call do something. Here you perform some side effect, yeah, in the SDK call. So this would be of the do something method inside the SDK interface. And change this to false to simulate failure, okay? Then we're going to change, yeah, you can do whatever you want here. So this is your SDK code basically, and when someone will call SDK dot do something, it needs to pass a callback and to override on success and on failure, and do whatever they want with on success and on failure, and that's it basically. So yeah, instead of main, let's have call SDK example. All right, let me see. Yeah, we just need to pass this. Import it, import. So when we have success bar executed successfully and full says full. Perfect. Oh, let me go to back to our SDK. I'm trying to think about something. Just a second. So this is the SDK interface wrapper. Okay, so let's see. Yeah, clean API, public API that hides the low-level interface delegation and exposes a friendly method do something with a success ready or callback. Let's see how it does that. Okay, that's what I wanted to do. So basically he has created an object and he has created a private val wrapped internal delegate. The user will never see this. And so basically it's now as do something is a static method that has this wrapper and then you can only call do something callback, and I like this better than before. So let's copy this. So the advantage here is that the user won't see this. Make callback public. Yeah, why did it make it yeah, private? I don't know. Internal, sorry. And here we have our call SDK example again. And we're going to go. Call SDK example. What has happened here? Import. Okay. Good behavior should be the same. We're just not calling full. How? I mean, what's happening? What's happening? I don't know. Okay, now it's working. I think it had an issue. The ID. Client got success. Operation completed successfully. Perfect. Okay, now let's do a 2 minutes break. And then I'll get back here. Because I want to go on with object declarations and expressions. Hopefully we have time. But yeah, just give me a few minutes. Okay, I'm back. I'm back here. So now that we have finished with our inline values class, we can go on with our with our class on object declarations and expressions. We can comment this, and let's go with object declarations and expressions. And here we're going to have a few readings. First on object declaration and expression. So object declaration, data objects, companion objects, object expressions. Yeah, so like expressions, unlike methods, seem to be. I think we have done this example in a similar way before. Access variables from anonymous objects. Okay, I think we have done something very similar already, so we'll go quickly, I hope, because we have to do 2 lessons in one. At least I had I wanted to have this lesson last time, but we didn't manage with time with the inline values, so I'll do object declarations as well today. So function. Objects allow you to define a class and create an instance of it in a single step. Okay. So this is useful when you need either a reusable singleton instance or a one-time object. So you can basically what you do here is you define a class and create an instance in one step. And it's useful when you need a singleton object. What is a singleton object or instance? It is something that you declare once and can reuse multiple times without having to recreate it, as you may do with the class. With a class, you can recreate that object many times. Here you can have a reusable singleton or a one-time object. To handle these scenarios, Kotlin provides 2 key approaches: object declaration for creating singletons and object expression for creating anonymous one-time objects. So object declaration for creating singletons and object expression for creating anonymous one-time objects. So the object expression is used to create a one-time object, and object declaration for singletons. I repeat many times the same things, but it's in order to ensure that we understand them. A singleton ensures that a class has only one instance and provides a global point of access to it. Using object declarations and object expressions are best used for scenarios where using singletons for shared resources, you need to ensure that only one instance of a class exists throughout the app. For example, managing a database connection pool. One instance of a class exists throughout the app. That's why you want to use singletons for shared resources. Then, creating factory methods. You need a convenient way to create instances efficiently. Companion objects allow you to define class-level functions and properties tied to a class, simplifying the creation and management of these instances. So One thing that I used many times is for example, companion object to define a constant tag that can be used for logging. So that's an example. Modifying existing class behavior temporarily. So you want to modify the behavior of an existing class without the need to create a new subclass. For example, adding temporary functionality to an object for a specific operation. So you can modify an existing class behavior in a temporary way without creating a new subclass. Type state design is required, so you require one-time implementation of interfaces for abstract classes using object expressions. This can be useful for scenarios like a button-click handler. Object declarations. You can create a single instance of objects in Kotlin using object declarations, which always have a name following the object keyword. This allows you to define a class and create an instance of it in a single step, which is useful for implementing singletons. So let's say you want to have a data provider manager that is a mutable list of data providers, and you want to have register a new data provider. You can do that with an object and say add provider that you're passing, and then you can show all of them with the get function. Yeah, with a get with a property that has a getter, which gives provider. To refer to the object, use its name directly. So you just need to use the name of the object, and then you can say register data provider. Object declarations can have supertypes. Similar to anonymous, objects can inherit from existing classes and implement interfaces. So they can inherit from classes like mouse adapter and implement interfaces. So I think we had an example we can take again, which is we have defined three examples at least. This one was with the view model. I think this was last time anyway. Yeah, and we have add event listener. So this is our class. And here we're passing an instance of customer event listener interface, which is an object. And we're overriding the on event method so that when we get an event happening, we can do something based on the event that is passed. And yeah, you will say when is this event called? Let's see. So on event is called with test1 and test2. So it's called when we're going to call these three methods of the model, and we just call listener. So it is our stored listener, which is the instance of custom listener that we added, and we just call on event at this point. So that could be our mouse clicked. Our on event could be our mouse clicked or mouse entered. And our view model dot mouse clicked would be called when we actually hit the click of the mouse, or mouse entered if we go inside a screen that and we enter it basically. Like variable declarations, object declarations are not expressions, so they cannot be used on the right-hand side of an assignment state. So syntax error cannot be bind to a name. Yeah, so you cannot assign them. That's what it's saying. Because they're not expressions. Object declaration cannot be local, which means they cannot be nested directly inside a function. However, they can be nested with other object declarations on non-inner or non-inner classes. When printing a plain object declaration, the string representation contains both its name and the hash of the object. So yeah, it will give the hash code. However, by marking an object with the data modifier, okay, you can instruct the compiler to return the actual name of the object when calling to string, the same way it works for data classes. Okay, that's interesting. I didn't know this. So basically, you can have classes and you can have data classes. We saw this in our lessons. And the advantage is that the data class has some methods like the toString, and this also applies to objects. So you can have data objects which actually print the object itself. So let me go back to our code, object declarations. Email password. What can we have here? Social number.pt. And here we have data object social number. And here we have number. This is just an example. So this is social number. And when we call it, first we don't pass anything, but if we print it, let's see what we have. Social number, so the name of the object. And yeah, of course, if we do that, we'll get 3. Additionally, it generates equals and hash code, so you can have in a equality check. Equality check here. Let me have social security number with 3. Let's do this. I imagine that it will not be the same. Yeah, cannot be applied. But what we might have, yeah, we're gonna have this either. How do you compare two objects, two data objects? Yeah, create instance via reflection. So yeah, you would need to create another singleton by forcing this using Java. So you shouldn't do this. So we're not even going to do this, but it creates a new instance of it. And then you can compare them. If you compare the two singletons, then it's going to say you're equal, and they will not be equal in memory. Yeah, this is to test the equality of the memory addresses. Of course, they will not be equal. So let's read this. The equals function for a data object ensures that all objects that have the type of your data object are considered equal. In most cases, you will only have a single instance of your data object, since the data object declares a singleton. However, in the edge case, where another object of the same type is generated at runtime, for example, using the platform reflection with Java Reflect, this ensures that the objects are treated as being equal. Yeah, of course, by reference, you will have inequality. Differences between data objects and data classes. So you will not have copy, and you will not have component end, because the data object is intended to be used as a singleton, so no copy function is generated. Otherwise, yeah, you would violate the idea of an object. Use data objects with sealed hierarchies. So I don't remember if we have had these with the view model. So basically, here when you define the state, you can either have a data object or a data class. So the idea here is that, yeah, what they're saying here is something like that is very useful. For example, when you define the states. Yeah, you will get a toString without the need to override it, but yeah. It basically maintains symmetry with the data classes. So companion objects allow you to define class level functions and properties. This makes it easier to create factory methods, hold constants, and access shared utilities. An object declaration inside a class can be marked with a companion keyword. So we have our data class here. For example, as you see, I have created the tag there. We did use it in here in the control flow. We have created a companion object with the seal class to basically play with our code. So we had our run functions and so on. or we have created a companion object that extends an abstract class. So yeah, we've seen this. This is used to create an instance of the class. So for example, let me see if we had this example as well. Not here. Yeah, here we're just creating a companion object, utilities of type abstract. But yeah, so this is kind of similar to what we had here. So sorry. Yeah, so these are called factory, apparently. Factory methods. Members of the companion object can be called simply by using the class name as the qualifier. So yeah, you can use user.create, and that will call the create method. So you can call these whatever you wish. And yeah, you will use general computer dot string capitalize and or capitalize, as you see here. Yeah, you see it capitalized. I'm calling this method basically. And I'm also calling this one in some other places. Yeah, each time inside this function, but whatever. Oh, why does it scroll? Shoot. Selection, companion objects. The name of the companion object can be omitted, in which case the name companion is used. So yeah, dot companion. We're calling this again. Class members can access private members of their corresponding companion object. So only a class member can access private methods. Yeah, private members of the companion object. Okay, so let's call this user.pt as user, blah blah blah. Where are we? Companion objects here. So reference one, reference two, okay. So if I have private null only in class member, you see, this way I can call it for in this way. So here we have this. And I won't be able to access user instance dot only class member. Let's go back to our app. And here, test object declarations. Import function. Perfect. Okay. Let's go on. Function string returns a string. All right. Returns another string. The members of companion objects in Kotlin look like static members from other languages. They are actually instance members of the companion object. So they're instance member of the companion object, meaning they belong to the object itself. This allows companion objects to implement interfaces. So yeah, we can say create the interface factory user t create CRUD main string and then t. And here we have factory CRUD import alias. Oh, import alias. CRUD, and we can right. Oh, user. So yeah, this would be inside the companion object instead. And then this will be overridden. And we're good again to go. So when we create the user, we can say factory user. And maybe here, all right, yeah, this is the instance. And here we have the user. And then we can have user instance dot create. What's going on here? All right, factory CRUD. Okay, name is not found. And the expose only is not found because their instance of user factory and not of factory CRUD. All right, that's interesting. So we will need to do as user. Testing never succeeds. It's factory user. How would this work? Factory CRUD user. Yeah, as factory, sorry. Yeah, that was factory. This is still not working. So, I mean, factory is the interface, right? And then we have user instance is factory thread user. So, what can we access here? Create equals. We cannot access expose or in class. And we cannot access name. That's because we have the interface here. I think the only way here would be to have this on our interface. But there must be some way to access user. So we're making a factory thread of user. Yeah, we're not actually accessing the class because otherwise I think it wouldn't be a singleton. We would be in a class. So this is why probably we cannot access them anymore. Let's try and ask ChatGPT why. So why can't I access name and expose only in class members? It is not a user, it's a reference to the user companion object which implements factory thread. You can access a name because name is a property of user class instance and not of the companion object. Okay. So it's not a property of the companion object. And name is a property. Sorry, then the companion object itself does not have a property name. Okay. If you want to access name, you need to store and use that instance. Oh, here's why. Now it makes sense because with create we're returning a user instance. That's what I wanted to do from scratch, from start. Sorry, I'm also a little bit tired. So yes, the idea is that you create with this factory CRUD, you return a type T, which is generic, and in our case, we are returning a user. And so each time we co-create, we basically create a user instance with something that we're passing inside our factory. Sorry, guys. So this is now solved. Let's go back to our example here. object expression. So object expression declare a class and create an instance of that class, but without naming either of them. These classes are useful for one-time use. They can either be created from scratch, inherit from existing classes, or implement interfaces. Instances of these classes are called anonymous objects because they're defined by an expression, not a name. So let's have, an anonymous object starts with the keyword object. The object doesn't extend any classes or interfaces. You can define an object's member directly inside curly braces after the object keyword. So yeah, that's basically it. This is an object, anonymous. Inherit anonymous object from supertypes. So yeah, you can have an anonymous object and, for example, pass it in the mouse listener. So this will be our listener that we're passing to our window, similar to what we had with viewModel dot listener event listener. And if a supertype has a constructor, pass the appropriate constructor parameter to it. Multiple supertypes can be defined separated by commas after the column. So you may have, you may want to inherit from different interfaces or superclasses. Like bank account is an open class and transaction is an interface. So you can have both of them. Use anonymous objects as return and value types. When you return an anonymous object from a local or private function or property, all the members of that anonymous object are accessible through that function or property. So you can have get preferences can be used from print preferences. This is similar to what we were doing before with the private members. Test private function Poli. So this will be private to the object. And if I try to pull it here, user dot, it's going to say create it. We're not here. Yeah, you see I'm private to the object. Yeah, I'm actually printing a function here. It doesn't make sense. This allows you to return anonymous type object with specific properties, offering a simple way to encapsulate data or behavior without creating a separate class. If a functional property that returns an anonymous object has public, protected, or internal visibility, its actual type is any. If the anonymous object doesn't have a declared supertype, the declared supertype of the anonymous object is there if there is exactly one such type. And the explicitly declared type is there if there is more than one declared supertype. In all these cases, members added in the anonymous object are not accessible. However, the members are accessible if they are declared in the actual type of the function or property. For example, blah, blah, blah. So you have an interface, two interfaces. Then we have a function notification manager, get notification. We have an object. So our notification is a generic object, but our email notification is actually a notification object. Yeah, notification instance. So we'll need to override notify user. And we're doing that. And then we also have a message. And then we also have detailed notification, which is an object, but it inherits from notification and detailed notification. And in this case, we're overriding notify user, and we're having a message. Yeah, we can do that without any issues. So we can copy this example to here. Right. Now we have our notification manager that we can use. Here. Let's import this. What can we do with our manager? We can do get. Why don't you? Yeah, it's a class. Crap. So we have to do it in a different way, like val notification this, and then that. What is going on here? So we have them all in this way, and they're all objects. So each time I call them, I create a new object. Like for example, an int equals random. Let's do this. Let's run it and see what happens. Yeah, undetailed. So undetailed. Of course, we have to print something. Otherwise, it doesn't make sense. And we want to print notify user. Oh, we didn't have. This should be as notification. Yeah. So let's do this. We don't really care about these two. we go back to the view. What? Okay. Run these, run. Yeah, as you see, this notification, that's what I wanted to show you. We're creating an object, and this is it's going to be a singleton. Let me try something different here. So now each time it's called, yeah, we have a different number. So the data inside the object is preserved, but notification manager is a class. So you might have something that is changing inside the class, like we have here a random. Our random is changing. So when you create an object 2 times, you will create it with a different random integer. And of course, if you declare a static property here, it will be the same each time. So it really needs to make sense. If you It really makes sense if you want to override something like notify user here. Okay, now we have our last topic is access variable from anonymous objects, and yeah, here we're just creating a function and creating a variable inside our function that will store the counter of click and enter count. And we can do the same with our previous example. Test1, test2. So here we're capturing results for test1 and expand this. And what you could do is you could say, let me see. Custom event listener. Oh, let's try something like define an integer, an integer value here, side effect calculated. And then let's go here and implement our side effect. We start with 0. Yeah, this is only get. Let me see. I don't want to get it. I want to have this, and then I want to have this and this. Yeah, it has to be variable. And in our custom event listener, must be a variable as well. So each time we call test1, we add 1, otherwise we add 2. And now let's try and okay, we have our add event listener, which adds the event listener. We want to print output of side effect. And since our listener is only inside our function, we should be able to return this. In this way, return integer. So output side effect, view model, the output side effect. And let's call this. So now we want to call more on classes. Let's run this. So this was a previous example we had. If you want to follow along with that, you should go to the nested inner enumeration inline values classes example. But specifically, we want to see this output side effect. So what we have done here is we have created a side effect variable that is changed each time we call the event, but from our listener object directly. This could have been calculated in a different way, of course, when we have the on event, when we call the on event, because when we call on event, here we would have the same variable as declared as private in our view model, or even in our let me see, custom event. Yeah, we could do something like listener dot update side effect. No, that wouldn't work. So this is a nice way if you want to have a variable that you later need to access after making the events, as we're doing here. So yeah, this returns listener side effect calculated. Some event. Yeah, maybe if you were passing the custom event directly from the, let's say, the UI, then here you will be able to add a when, and you would be able to like, I'm doing it, custom event. I'm passing a custom event, so I can say when we have a custom event in which event type is one, then we can do something like all custom my private side effect calculated, and here I have an integer of 0, and here I can say plus equals, yeah, plus equal 1. Yeah, it has to be a variable. It was okay. So test2 in my set effect plus equals 2. Okay. So that will behave the same, but this way, of course, we need to pass everything from here. Some event test1 1, and that will calculate the side effect anyway. But this way, you're not storing it inside your custom event listener. That's the only difference, I would say. Maybe what you could do to solve that is call listener.side effect and have side effect, yeah, my private side effect calculated equals, yeah, that would make sense as well. If you don't want to have this side effect plus equal 1 and plus equal 2 here, you could do it in the way I'm doing it here. Let's try and do this and run it. So we have side effect. Yeah, it has worked. Because so we're assigning test1. We're running test1, which runs an event with test1. And we're using this +1, and then we're using +2, and then we're using +1 again. And we're placing it inside side effect calculated. Each time it will be auto incremented. And for this second part with test custom event pass, we're calculating with a private property in our view model +1 +2. And then we're assigning a side effect. Yeah, the listener side effect, the private variable that we want to assign, which in this case is the custom view model private property. So we have seen two different ways to instantiate variables inside our objects. In this example, we have a view model in which we want all the logic in the second example. And in the first example, we have some logical part, or yeah, logical part on the where we call the view model. It's clean in both ways, I would say. It depends on what you need to do. So thank you very much, guys, for watching this. I hope you enjoyed it, and if you did, please like and comment. For the next videos, I would like to do something a little bit different. I mean, I would love to do some contribution on a open source project, and maybe I will see if I have some more extra time to stream during the week. Yeah, probably not during this one, but maybe next week. So thank you guys for watching, and I will see you on the next one. Peace.